Question 1. Now, question 1 is a standard form question. Write the resident population in 2010 in standard form. Correct to 3SF. So 3771 is approximately equal to 3.77. And because you know that this is in million, right? Technically, if it's in million, you can just directly multiply by 10 to the power of 6. You ought to know that million is 10 to the power of 6. Okay? And they want the answer in 3SF. So you just leave it as such. No working required because it's just a 1-mark question. Calculate the percentage increase in the resident population from the year 2000 to the year 2020. Basic primary school percentage increase, decrease. So you must know that if they tell you from this year, then this is your denominator. Or this is your original. Okay? So your percentage increase. Common mistake that students forget. 2023, paper 2. Percentage increase must remember to find difference. So that's the common mistake that some students will make. So your percentage increase here is given by your difference, which is 4044,210 minus 3273,363. The whole thing out of the original, which is 327,3363. Then times 100%. Because this is a 2-mark question, you must show the step. If you don't show the step, you don't get the method mark here. So mark allocation, same thing applies, right? If it's a 2-mark question, then you jolly well show your step. So 4044,210 minus 327,3363 over 327,3363. Then you multiply by 100. This will give you 23.5% in 3SF. Okay, don't need to leave it as a fraction here, even though it is technically not wrong. The number is so big that you should always leave it as a decimal in 3SF. Okay? If you didn't show the working step, then minimally minus 1 mark. Next. In the year 2000, 18.7% of the total population was non-resident. Read what the question shows, right? The question shows your resident population. So if 18.7% is non-resident, that means 100 minus that will give you your resident population. And this is in the year 2000. So the first thing you should figure out is how many percent is resident population. So you will find that 81.3% is resident population, which means that this number over here represents 81.3% of your total population. Right? You are not in primary school, so I don't want to see this, which sometimes I still see in some of your work. The moment we see this, it's a minus presentation mark. Okay, in secondary school, if you want to write, you have to write 81.3% of population in 2020 equals to 327,3363. Right? And therefore, total population in 2020 is given by 327,3363 divided by 81.3 times 100. Here, you cannot put a percentage sign there. If you put times 100%, then it's wrong. So don't anyhow put the percentage sign. That's why sometimes it's a lot safer to just not put units for anything, except for degrees. Okay, so this will give you 4026 277 to the nearest whole. I would leave the answer in nearest whole. My understanding is for that particular year, Cambridge accepted 3SF value as well. So you could also have left the answer as 403.00000 to 3SF. Cambridge accepted that as an answer. Okay, but I wouldn't have left it as 3SF. I would have left it as nearest whole. Obviously, you cannot leave it in any decimal value because your population can never be a decimal. And that's why I think the reasonable answer to leave it is nearest whole. Part B, population density is defined as the number of people per square km. In 2020, population density of Singapore was 7810 per square km, and the total population of Singapore was 5.69 in 2020. Calculate the area of Singapore. You know our population now in Singapore is more than 6 million already. Which also means in under 5 years, our population increased by 400,000. That's the amount that our population increased by. Our total population in Singapore now is above 6 million already. Now, to calculate the area, if you take job, then you should know what's the formula for population density. The one got no excuse. If you don't take job, you look at what they gave you, right? They tell you that it's defined as the number of people per square kilometer. So what does it mean? The unit here is people per km square. That is the unit here. Therefore, if you look at this, right, 7810 people per km square is obviously equal to your population, right? Because people here clearly is a numerator, which is 5.69 million. So you can just 2 times 10 to the power of 6 over your square kilometers. Right? And therefore, to find area, I've already taught you previously, you can just directly, if you are finding like this, you can just directly swap the number to the denominator. Right? If not, you can go and multiply it out. Okay, you let the area be x, then you will have 7810x equals to 5.69 times 10 to the power of 6. Then you should know how to find x. But you should know that you can just swap the position of these two numbers in the fraction, and therefore it is just 5.69 times 10 to the power of 6 divided by 7810, and you will have 728.5, so you round to 729 in 3SF. Okay. So far, if you look at this page, 7 marks, but all the 7 marks are very, very straightforward. Right? Cambridge effectively gave you like free 7 marks. Anybody did not get these 7 marks, you will be very sad. But the next question, not so straightforward. So what did they test in the next part? Next part here, for 3 marks, they test you, technically this is a what type of question? This is technically a map scale question, but they combine map scale with standard form here. So that's number 1. Number 2, they test map scale in a way that you are usually not used to. What do I mean by you are usually not used to? Normally, your scale drawing is smaller than the actual diagram, right? Whether you are looking at, like they like to give like maps or, the floor plans and things like that. In all of those cases, your actual value is greater than your scale drawing. But obviously, in this case, when we are talking about a red blood cell, your scale drawing is larger than a red blood cell. And that's why instead of your usual method of 1 to n, right, for your scale, you notice that they ask you to find in terms of n to 1 and not 1 to n. Why? You must understand how to read a map scale. This is always your drawing scale. And this is always your actual scale. So when I have 1 to 5,000, it means that my drawing is 1 unit, my actual will be 5,000 units. But in this case, it's the reverse. Because my n, you should know, is going to be larger than 1. Because the drawing has to be larger than the actual red blood cell. Right? So how do we find the value here? If you understand that this is drawing to actual, we know that it is n to 1, right? So your scale drawing here, they tell you that it's 3.9. And when it's 3.9, what's your actual? It is 7.8 times 10 to the power of -6. Therefore, how do you find n? Here, obviously, you have to divide by 7.8 times 10 to the power of -6, right? So you will take this and you will divide by the same thing. Okay? So that is how you should do the question. So many students that year gave very weird answers because they don't realize that n has to be larger than 1. So you will have 3.9 divided by 7.8 times 10 to the power of -6, which will give me 500,000. But what's the second mistake that the students make? Never pay attention to the unit. So your 7.8 times 10 to the power of 6 is not in cm, it is in meters. But this is in cm. So you cannot put 3.9 here, right? What should the 3.9 have been? The 3.9 needed to be 0.039 meters. And that's why sometimes for map scale, you will want to put the unit. The unit will eventually disappear because it will cancel out. But a lot of students will make this mistake where you forget because you don't write the unit and then you don't realize that they're actually not the same unit. So your numerator here should have been 0.039 so that you get the answer 500,021 in the correct unit. Okay, and therefore n is just 5,000. All right. So they don't commonly test it in reverse like that, right? But the logic remains the same one. It's just that this time you must understand by logic, your drawing has to be larger than the actual red blood cell for obvious reasons. Okay. Also, we need to see the step. We need to see the divide by 7.8 times 10 to the power -6. Otherwise, you cannot get the mark. Next, drawn to the same scale as red blood cell, the diameter of a platelet is 8 mm. Find the actual diameter of the blood platelet. If you are looking for the conversion, actually, if you are looking at mm to cm conversion, what do we look at? You just look at your ruler. Your ruler shows the markings in mm's. Your marking on the ruler is actually in millimeters. So if you actually look at your ruler, you will realize that 10 mm is actually equal to 1 cm, not 100. Okay? And it stands to reason because millimeter means out of 1,000, right? Milli means 1 out of 1,000. Centi means out of 100. So out of 100 and out of 1,000, obviously the difference is 10 times 1. All right. But the question actually doesn't require you to know the conversion. Because from part A, we are given, right, n to 1 is in the ratio. Your drawing to actual is in the scale 5,000 to 1. 5,000 to 1 will mean what? It will mean if it is 5,000 mm, it will be 1 mm. So you can actually just put this in mm, right? And this will just give me 40,000 mm with the unit. 5,000 to 1 does not have unit because the unit is the same and therefore they will cancel out. But because the units are the same and they will cancel out, you can just replace the units as long as they are the same units, isn't it? Therefore, your actual diameter is 40,000 mm because you need to times 8. And then you will tell me that 40,000 mm is equal to 4 times 10 to the power of 1, 2, 3, 4. Okay? So actually it's meant to be very straightforward one for 3 marks. All right. Oh, wait. What mistake did I make? What mistake did I make? Also, if your platelet is this big, this is absolutely fantastic. Then your blood will absolutely stop flowing. It is the drawing that is 8 mm, not the actual. Okay, if your actual platelet is 8 mm, then something is very wrong already. Correct or not? How can your, especially those of you who take bio, how can your platelet be 8 mm? You know how big is 8 mm not? 0.8 cm. Can you imagine your platelet being that big? Then your blood will literally stop flowing. What does platelet do? Platelet helps your blood to clot, right? Can you imagine your platelet is that size, is larger than the size of your, if you think about it, it's larger than the size of your artery. Your platelet bigger than the size of your artery. Amazing. It is in reverse order. I read the question wrongly. The drawing is 8 mm, not the actual. So the drawing is 8 mm means it should be like that. Then to find this, you divide it by what? I think 625, is it? Yes, 625. And therefore you will get 1 divided by 625 is 0.0016, but they want the answer in standard form. Let me write in the unit first. So 0.01016 mm is equal to, this time round you move the decimal point the other way, right? So it's 1, 2, 3 to get to standard form. But you must remember, because the number became larger here, right? This is now 1.6. You have to times 10 to the power negative 3. It is not times 10 to the power 3. Okay, now this looks like a reasonable size of a platelet, okay? Not the size of a platelet that will cause your blood. Not that the platelet, the platelet won't even need to clot your blood because you will block up your entire artery and kill you already. That no clotting required when the person is longer alive. So please read the question carefully.